Let us solve few questions using second law of motion. Now what is second law of motion? The force is directly proportional to rate of change of momentum. Means when we apply force to a body, what happens? The momentum of the body changes with certain time. So this rate of change of momentum with time will give me the force. And we can find this equation F is equals to ma. We have already discussed about it in class. Now let us see the numericals. So, first thing is, if I have a mass and if I apply a force on it, what will happen? The body will start to accelerate in this direction. Yes or no? So, what is the acceleration? Let us see what are the forces that are related to this mass. So, if this is mass m, mg is acting downwards, normal reaction upwards, force in this direction. So, if I want to draw the free body diagram, and with the help of it, if I want to find the acceleration, then what to do? Here mg downwards, n upwards, f in this direction. So we have already seen there is no motion in upward. The body is directly moving like this. It is not going up or down. This means that n is balanced by mg. So n is equals to mg. And the second thing is when the body is moving in this direction. So F force which is applied is moving the body in this direction. Acceleration is A. So this force will be equals to what? M into G, mass into acceleration. So from here we get A is equals to F by M. So this is the new concept that we studied, that when some body is moved, okay, when it is not in equilibrium, rather it is moving. So when it is moving means some force is applied. Now the force which is applied is equals to mass into acceleration, and the direction of the acceleration, this will be direction of force. Now force can be applied from many directions. Okay, force can be from different direction, but acceleration will have only one direction. Yes or no? For example, if this is the mass, F1 force is applied in this direction, F2 force is applied in this direction. What is given? F2 is greater than F1. Okay, find the acceleration. So we have to find the acceleration's value. Now when two direction forces are applied, can I draw it like this? If this is F1, this is F2. F2 is greater, then will the body move in this direction or this direction? When F2 is greater, so force here in this direction is greater, so body will also start to move in this direction only. This will be the direction of acceleration. Yes or no? So I can draw the free body diagram like this: mg downwards, n upwards. This force F2 in this direction, this force F1 in this direction. So first thing is n is equals to mg. Okay, and next one is, which one is greater? F2 is greater than F1. So net force, some force of F1 will cancel this, but the extra, the part that is greater will accelerate in this direction. So what is this extra force? F2 minus F1. We will take this as positive and we'll take this. Always remember the direction of acceleration is taken as positive. So this will take it as positive, this will take it as negative. So F2 minus F1 is equals to m into A, mass into acceleration. This is the net force, this is the mass into acceleration. So A is equals to F2 minus F1 upon m. Now let us consider the force which is acting with some angle. Suppose this is the horizontal. Okay, so from the horizontal, suppose it is making an angle theta. Now I want to find the normal reaction and the acceleration of the body. So now let us see what are the forces related to it. So if mass m, then mg is pulling it downwards, normal reaction upwards. This is the direction of force. Now I cannot solve it like this. So I have to resolve this force in two components. It is given that this side is theta, so this will be f cos theta and this will be f sin theta. So let us draw the free body diagram. So this is the mass m, so this is the mass m. Now here mg downwards, normal reaction upwards, f sin theta upwards and f cos theta in this direction. Let us see what is the direction of acceleration. When we are applying this, it is said that the acceleration which is happening is in this direction, forward direction. So n plus f sin theta, in upward and downward there is no acceleration, means this direction force and this direction force is balancing each other, it is in equilibrium. So n plus f sin theta must be equals to mg. But here in this direction, f cos theta, here is the acceleration. So acceleration is equals to the force which is there, this only. So f cos theta must be equals to m into A. mass into acceleration. So this force and this force are now okay, fine. So A, from here we got F cos theta upon m. So we can find the normal reaction and your acceleration by putting the values if it is known. For example, let us see one more question, you'll understand. Suppose there are two masses T1 and T2 attached with a string, and I'm pulling it like this. Okay, I'm applying a force in this direction. I'm applying a force in this direction. Okay, this direction. So what is happening? We want to find the acceleration of m1 and m2. What is the acceleration of m1? What is the acceleration of m2? Now, as I said, forces can be acting in different directions. But since the mass is related, attached together, so whatever acceleration will be there, same acceleration will be for both the bodies. So acceleration A. Now let us see the forces. m1, mg is applying downwards, n1 is applying upwards, m2 is applying down, n2 is applying upwards. So here the upward and downward forces are balancing each other. Now let us see what are the directions, okay, of tension. So here we can see away from the body T, here again away from the body T. Now here same wire, so same tension, and force is applied here F. These both are balancing each other. The bodies are not moving upward or downward, it is just moving in forward direction. So let us draw the free body diagram. So we can leave this two also because these both are balancing each other. Now if I see this one, so T, this force must be responsible for the acceleration. So T must be equals to mass into acceleration. Okay, responsible for acceleration means what? The force which is responsible for the acceleration should be equals to F is equals to mass into acceleration. So this force is T force and this is acceleration, so mass into acceleration. In the same way, here if we see again, here F is also there, T is also there. So F minus T, this acceleration is in this direction, so F is greater. So F minus T, this is positive, this is negative. F minus T is equals to mass of this body into acceleration, m2 into A. Now I know T's value from here, so I can put the T value. Now we can find the acceleration like this. A shortcut is also there for it. If suppose there are two masses and it is given like this, if I want to find directly the acceleration, not the tension, there is no shortcut for finding the tension. But directly if I want to find the acceleration, I can do it. A is equals to F net upon M. F net, whatever is given we'll do, write it, and M net, M1 plus M2. So F upon M1 plus M2. In this way we can do it. So the same type of question, here 2 kg mass, here 1 kg mass, and here 3 kg mass. A force of 60 Newton is pulling it. Okay. So here we want to find the tension and acceleration. Again we'll draw the free body diagrams. First let us see what are the forces. So for 2 kg away from the body is T1. For 1 kg away from the body is T1. Okay. For 1 kg again there is one more rope. So here T2, and here 3 kg there is T2. This normal reaction and mass, your weight, both are cancelled. So since there is no motion upward and downward, only the acceleration in forward direction. Let us see 2 kg mass here in T1. So this T1 is causing the acceleration here A. So whatever acceleration is there is due to this force only. So force is equals to mass into acceleration. So T1 is equals to mass is 2 into acceleration is A. Similarly, if I want to do it for your this 1 kg one, so here T2 is there and here T1 is there, but the acceleration is in this direction, means this is positive, this is negative. So T2 minus T1 is equals to A. So in place of T1 I know it is 2A, so I can put the value 2A. I can write it 2A, T2 minus 2A is equals to A, so T2 is equals to 3A. This will go this side, so T2 is equals to 3A we got from here. Let us see then this one. Okay, now here this is 3 kg, here it is 6 Newton, here it is T2. We know that the body is accelerating in this direction, so this is positive, this is negative. 6 minus T2 is equals to 3. Again solve it. T2's value we know it is 3. Put the value of 3A. So 6A is equals to 6 is equals to 6A. So A value will be 6 by 6, that is 1 meter per second. Now in place of acceleration I can put the value of A. So 1, so that is 3 Newton. T2 is 3 Newton. Similarly T1 is 2 Newtons. Last one, our pulley system question. Now here what is there? There is a pulley. This is of mass 1. This is of mass 2. It is given M1 is greater than M2. M2 is greater than M1. So when some mass is greater, okay, if this is greater, obviously the motion will be like this. wherever you hang the heavy thing, it will fall like this. So m2 is greater than m1, so acceleration like this, and this m1's acceleration will be this a, but acceleration's value will not change because the system is tied together. Let us find the tension and acceleration now. What is the value of this acceleration? So let us see first this mass. For this mass m1, mg is pulling it downwards, T tension is pulling it upwards. For this mass m2, m2g is downwards and T is pulling it upward. Now if you see the acceleration for here, it is like this. Body is moving like this. Okay. So this means that this is positive and this is negative. This is more and then this. So this will be positive, this will be negative. T minus m1g will be equals to the net force, that is m into a, m1 into a. And for this, we know the body is accelerating like this. So here this is positive and this is negative. So m2 into g minus t must be equals to m2 into a, like this. So we have two equations, two variables, we can easily find it. So m2 in place of t, first you add the equations, so t and t get cancels out. So here what we will get, m2g minus m1g, and here m1a plus m2a. So take out a common, put it here, so we get the value of acceleration. In next step, if I want to find the tension, put the value of acceleration in any of the one equation, we'll get the value of tension. So in this way we can do the questions. We can have the normal values. You see in NCERT textbook there is one example also, you do it by yourself. Okay.